graph is shown to you and a train moves from one station to another in 2 hours of time, right? And its speed during the motion is shown in the graph. So let us draw the graph first. Okay, into the graph, into the y-axis we have speed in kilometer per hour. Here we have the speed kilometer per hour, in kilometer per hour, right? Like this. And so this will be the speed. Here we have the speed, right? Now after this, into the x-axis we have time, right? The unit of speed is kilometer per hour, and here we have time in hours, right? So into this graph, what is shown to you that need to be understood. Okay, the graph is drawn like this, right? After this, an horizontal line. After this steep slope, right? After this, it immediately falls down like this, right? Now this time stamp is given to you. This time stamp is 0.5, this is 0.75, and this one is 1.0, and this one is 2.0. Since the train is traveling from 0 to 2 hours, so for train's journey it's given that for 2 hours of journey this graph is plotted, right? And here is 20, and the peak speed is 40, right? So this is given to you. Now we need to find in this question that here it's given that the train moves and follow this path, right? And this is a speed time graph, speed and time. Speed is plotted against the y-axis and time is against the x-axis, right? Here the train moves like this and from one station to another in 2 hours of time. So here from 0 to 2, total 2 hour of time is taken by the train, right? And this is shown into the graph. Its speed during the motion is shown into the graph. Determine the maximum acceleration during the journey. So students, the maximum acceleration. So what is the formula of acceleration? It is its velocity by time, right? Its velocity by time. So for the different stamps, let's say A to B, B to C, C to D, D to E, there are different accelerations across this stamp, this stamp, this stamp, and this stamp. But has been asked into the question, what is the maximum acceleration? The acceleration, what is the maximum in this graph? So here you can see velocity into the numerator, and when it will be maximum, that means the maximum slope, that means here you can see from 20 to 40, right? The maximum steep you can see, the inclination over here is maximum. Here you can see this one, right? Just standing, kind of. So the maximum velocity over here can be calculated as 40 minus 20, right? So this will be 40 minus 20 in kilometer per hour, right? Divided by what will be the time. So from 20 to 40, it from the train speed increasing from 20 to 40. So how much of time this attains the velocity from 20 to 40? The time will be 0.75 to 1. So into the denominator it will be 1 minus 0.75, that is 1 minus 3 by 4 hour. Here the speed or the velocity is in kilometer per hour. So kilometer per hour into the numerator is the unit of velocity, and in the denominator the times unit is in hour. Now 1 minus 3 by 4 is 1 minus 3 by 4 is 1 by 4. So this will give you 4 into go into the numerator, 4 by 1 into 20, that is 80 kilometer hour into hour per hour square is the acceleration. This is the acceleration. 80 kilometer per hour acceleration is the acceleration which is maximum, right? So for any questions of such graphs, when this is asked to you, then you need to see for maximum acceleration the maximum slope, right? Here this is the max slope, right? So since this is the maximum slope, this will give you the maximum acceleration, right? That means this value 40 minus 20, this one divided by this value time, right? This will give you the maximum acceleration, right? Change in velocity by change in time, right? That is delta. Here you can see delta, delta, right? Now what we need to calculate? The second part, the distance covered during this interval. The distance covered. So the distance covered during the time interval from 0.75 hour to 1 hour, that is the distance covered will be equal to distance covered during this time. Which time? When this maximum acceleration of maximum value is attained, right? Distance covered during this time, that means 0.75 to 1. So this will be equal to the area which will be covered into the velocity time graph. So this will be the area. So I am trying to highlight it with here. This will be the area, right? Here you can see these are two parallel lines because both of these are at 90 degree, right? This line and this line is parallel. So let's name them A, B, C and D. So distance covered during this interval equal to will be equal to area of what? Area of trapezium A, B, C, D. This one, A to B, B to C, then C to D and D to A. So what is the area of a trapezium? These are two parallel sides AB and CD, right? So area of the trapezium is half into sum of parallel sides. So AB, here you can see AB parallel to CD. So the sum of the parallel sides, that means AB plus CD into the distance between the parallel sides. What is the distance? Here BC will be the distance. So into BC. So this area of this trapezium will give you the distance covered during this time, right? When the maximum acceleration is attained, right? Now, just put up the value to get the distance covered. So, it will be equal to half into sum of parallel sides. So, parallel side CD, you can see CD is 40. So, this will be 40, right? So, in place of AB, in place of AB, it will be 20, right? Right. So, first write the value of AB, that is 20 plus CD. CD is this much, that is 40, right, into BC, B to C, that means 0.75 to 1, that is 1 by 4 hour, which we have already calculated, right, 1 by 4 hour. So into 1 by 4. So this will give you the distance, distance covered during this time, and the value of this will be 1 by 2 into 60 into 1 by 4, right? So 4, 15, 60. 4 into 15 will be 60, right? So here you can see, yeah, here you can see the value as 15 by 2, which is coming as 7.5. 15 by 2 is 7.5 kilometer. 7.5 kilometer, right? So in this way we have solved this question, right, students? For any query you can put up into the comment box, I will respond it. Okay, thank you so much for watching. Bye bye, take care.